Okay, so now we're going to get into specific sequences. So in 11.2, we're going to talk about arithmetic sequences, not arithmetic, arithmetic. It's an adjective, a descriptor. So what is an arithmetic sequence? Well, it is a sequence in which a common difference d is added to each term to get the next term. So it's important that you understand that definition. We are adding something to get the next term. What we're adding is a d value. So if you were told that you have a sequence where d is equal to 2, that implies that this is arithmetic because d is what you're adding. So let's look at some examples. The first one, you have 3, 9, 15, 21. This is arithmetic because you're adding 6, so d would equal 6. The second one gives us 11, 4, -3, -10. This is also arithmetic because you're adding a -7. D is equal to -7. You may say, well, we're subtracting 7. Yes, but because the definition has to be what you're adding, we need to think of it as adding a -7. Now on the third example, this is not arithmetic because when you go 2, 4, 8, 16, you're not adding the same thing every time. Now, you may say, well, we're multiplying. We are multiplying, that's going to come later, but it's not adding, so it's not arithmetic. Now, as we deal with these sequences, what we're going to be talking about is writing explicit formulas and then finding specific terms. It's important that you really pay attention to how to write an explicit formula. I had another class that never really got this concept. If you are told to write an explicit formula, here's the formula that you're going to use here in bold. It says a sub n equals a sub 1 plus d times n minus 1, where a sub 1 is the first term, d is the common difference, that's what you're adding, and then a sub n is the nth term. Writing an explicit formula means you leave it as a sub n equals, you fill in the numbers and you simplify it. So look at the next example and pay attention to how the answer is written. It says write the explicit formula for the nth term of a sequence, 8, 15, 22, 29. So think about what you're adding. Your d value is 7 because you're adding 7 to every term to get the next one. So if we take our a sub n formula, a sub n equals a sub 1 plus d times n minus 1, we could substitute 8 for the a sub 1 because that's the first term, and we substitute 7 for the d because that's what we're adding. But then notice what we do. We're going to distribute the 7, and then we combine like terms. So we write our answer as a sub n equals 7n plus 1. Make sure that you distribute and combine like terms. You want this simplified. So this would be our explicit formula, meaning if I continue on and say find the 50th term of the sequence, all you have to do is plug 50 in for the n, and when you do that, you get 351. So if you kept going by adding 7 and got to the 50th number, you'd be at 351. The next example says write the explicit formula for the nth term of the sequence 97, 88, 79, 70. This time, notice what we're doing is that we are adding a -9. So we take our explicit formula, a sub n, and we substitute 97 for a sub 1 because that's the first number. We substitute -9 for d because that's what we're adding. When you distribute that -9, notice that you get -9n plus 9, and combining our like terms would give us 106 minus 9n. If you want to write it as -9n plus 106, that's fine. So if I ask you to find the 27th term, you just plug in 27 for the n, and you'd get -137. Now, with arithmetic sequences, you may also be asked to find what's called the arithmetic mean. That word mean is an average. So the arithmetic mean of any two numbers is simply the average of those two numbers. So the first example says find the arithmetic mean of 85 and 117. You're going to add the two numbers and divide by 2. It gives you 101. That's it. Be careful on your calculator. If you want to do this all in one line, you have to put parentheses around the 85 plus 117 before you divide by 2. The second example is basically the same question, it's just asked in a different manner. It says find the missing term in the arithmetic sequence, something all the way to 18, and then there's something between 18 and 42, and then it continues on. But because they tell you it's arithmetic, this is another way of asking for the arithmetic mean. So you just add 18 and 42 and then divide by 2, and that gives you 30. You could extend this if you, on the third example, it says find the missing terms in the arithmetic sequence 1 blank 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 73. So now there's 3 numbers in between 1 and 73. Well, what you can do is you can simply find 3 arithmetic means. So if you start with the 1 in the middle, you would do 1 plus 73 and divide by 2. That gives you 37. Then, so if 37 is in the middle, now you can do 1 plus 37 divided by 2, and that would be 19. Then 37 plus 73 and divide by 2, and that would be 55. So going back to the question, the original sequence here, you'd have 1, 19, 37, 55, 73. And that's how you would get the missing numbers between 1 and 73. So you see your homework here on page 608 listed, and make sure you get that turned in to me.